All right, here are solutions for quiz 6, Math 251. For the first problem, you're given a couple of derivatives here and asked to find what the derivative is. So it's a whole lot of chain rule. So for this one, you're taking the derivative of this mess, which really it's a sum. So you're trying to figure out the derivative of this first term. And then if you can figure out that, you'll just add that to the derivative of this second term, which you can then add to the derivative of this third term. And two of these guys are easy. One of them's a disaster. This first one is the disaster. To take the derivative of this mess, well, you want to recognize you got a chain rule going on. The outer function is 2 raised up to some stuff. So the derivative of 2 raised up to some stuff is 2 raised up to that stuff times the natural log of 2. But then you're not done. You still have to multiply that by the derivative of that stuff. So all of this goes to this, and then the derivative of 2x is just 2, and the derivative of 2 is 0. So I still have a little bit of calculus left to do in here. I get 2 raised up to the x squared plus 2x plus 2 times the natural log of 2 times this derivative, which happens to be 2x plus 2, and then all of that plus 2. So kind of a disaster, kind of ugly looking. Could you clean this up any? I guess a little bit if you really wanted to, but I wouldn't. I'd leave it just like this. So I'm going to leave it just like this and call that my answer. And then this one. So kind of similar. You're taking the derivative of just a huge mess of things, kind of making sense of what it's even asking is half the problem. We have a bunch of stuff being squared. So my outermost layer is this stuff being squared. And then what is being squared? Well, it's x squared times the sine of x squared squared. So instead of writing sine squared of x squared, I'm going to write sine of x squared squared, so it's more obvious what is each layer. So my outermost layer is this stuff in green right here. So if I take the derivative using the chain rule, I get 2 times, and then I'm going to leave all this stuff in red alone, x squared times sine of x squared squared, which you could write like that if you felt like it. But then I'm not done. I still have to multiply that by the derivative of all the stuff in red, which was x squared times the sine of x squared squared. And so to figure out this derivative, maybe you'd recognize that you got a product rule going on here. Playing the role of f in our product rule is x squared. Playing the role of g in our product rule is sine of x squared squared. So f prime's easy enough. That's just 2x. G prime is going to involve some work to figure out g prime. She's running out of colors. That's how you know a problem's too hard. I'm going to have to take the derivative of this thing. So maybe down here, g prime equals the derivative of something being squared. What's being squared? The sine of x squared. Okay, so how do I take this derivative? It's chain rule. Let's see if I got my parentheses right. That goes with that. There. It's chain rule. My outermost function is the stuff being squared, so I'll bring the 2 down in front and leave everything else alone. Sine of x squared. But then I'm not done. My next layer, I have to multiply that by the derivative of the sine of x squared. And so to take that derivative, let's just leave all this stuff alone. The derivative of sine of something is cosine of something. But then I have to multiply that by the derivative of the something. So what I get is 2 times the sine of x squared times the cosine of x squared times 2x. In other words, 4x sine of x squared times cosine of x squared. This entire mess goes right there. F prime, G prime. I'm essentially done. Just got to apply the product rule. So I'm going to take all this stuff here, and I'm going to write it right here. F prime, which is x squared, plus g, or f prime times g, which is the sine of x squared squared, aka sine squared of x squared, f prime times g plus g prime, this thing, 4x sine of x squared cosine of x squared times f, which happens to be x squared. So I can clean that up a little bit. I guess I call it 4x cubed. But don't forget you still have all the green stuff here. So it's really 2 times x squared times sine squared x squared times this thing. Or if you really feel like cleaning stuff up, let's see if I can clean it up. I got a 2. Oh, I have 2 terms here. Yuck. Okay, so maybe I'll keep those separate. Let's say 2x squared sine squared x squared times, and then this term is x squared sine squared x squared plus, and then 4 times x squared, I guess I could call that 4x cubed, sine of x squared cosine of x squared. Wow. Might have gone a little bit overboard on that one. Sorry about that. Either of those would work as your derivative. Whew. And then if you finally get through that, you turn it over and you see this mess, you say, oh man, implicit differentiation, I got this equation, and I want to find the slope of the tangent line. Got a couple options here. Option 1, if you expand the left-hand side, you'll get x squared plus 2xy plus y squared is equal to y over 2 plus y over 2. Equals 2 to the y power plus 2xy plus 2x squared. Note that I could subtract 2xy from both sides of the equation, and I could subtract an x squared from both sides of the equation, and I would get y squared plus y over 2 equals 2 to the y plus x squared. Subtracted that from both sides and then got rid of one of those. And now I can take the derivative of both sides. The derivative of y squared plus y over 2 is equal to the derivative of 2 to the y power plus x squared. So the derivative over here, the derivative of sum is the sum of the derivatives. So I take the derivative of each parts individually. The derivative of y squared is 2 times y prime. That's the chain rule. Take care of the stuff squared, you get 2y. And then multiply that by the derivative of the inside function, which we're using y prime to represent. Derivative of y over 2. Well, y over 2 is just 1/2 times y. So the derivative of 1/2 times y, bring the 1/2 down in front, and the derivative of y is y prime. You don't need a quotient rule here, although I imagine a lot of people used it. The derivative of 2 to the y power. Well, if it were just 2 to the x, my derivative would be 2 to the x times the natural log of 2, but it's not. It's 2 to the y, so I need a chain rule. I'll leave the y alone, and then I'll multiply by the derivative of y, aka y prime. That gets me here. And so I got 3 terms that have y primes in them. So I get them together on one side of the equation. I factor out a y prime. And I divide to get that y prime is equal to 2x divided by 2y plus 1/2 minus 2 to the y times the natural log of 2. That's one option. The other option is you don't expand. So option 2, I don't know, brute force. The derivative of the left-hand side, well, I'd need a chain rule here. I'd bring the 2 down in front, leave the x plus y alone, and then multiply that by the derivative of x plus y, which is 1 plus y prime. And then to that I want to add the derivative of y over 2, which is y prime over 2, or 1/2 y prime. And then the right-hand side, 2 to the y, the derivative, as we saw, is 2 to the y times the natural log of 2 times y prime, plus the derivative of 2xy. I would need a product rule. Playing the role of f is 2x maybe, and g is y, I guess. And so f prime would be g would be 2, and g prime would be y prime. And if you mash all that together, f prime times g plus g prime times y gets me that stuff. And then the derivative of 2x squared is 4x. So I get this mess, and then I want to solve that algebraically, which I don't really know where I'm going to do that. I'd have to expand this, so I'd get 2. Let's see, okay, so maybe I FOIL first. X times 1 is x, and then multiply by that 2, I get 2x. Y times 1 is y, multiply by the 2, you get 2y. X times y prime gives you 2xy prime. Y times y prime times the 2 gives you 2y, y prime, plus 1/2 y prime. That's what I get on this side. And then on this side, I get this same thing. And so I'm going to collect all the terms that have a y prime in them on one side of the equation. So let's jump all the way down here. This kind of got in the way there. And so I got 2xy prime plus 2y y prime plus 1/2 y prime. Do I have any y primes on this side? Yep, sure do. Subtract them over to this side. 2 to the y, natural log of 2 y prime, minus 2x y prime. I think that's all the terms that have a y prime in them. And that equals what was left over here, a 2y plus a 4x, plus any terms over here that did not have a y prime in them. I have this 2x and this 2y, so I guess I could have subtracted those. And so I have 2y minus 2y, or 0, and 4x minus 2x, I got 2x. And so if you factor out a y prime here, you might also notice the 2xy prime and the 2xy prime cancel each other out. So I just get 2y y prime plus 1/2 y prime minus 2 to the y, natural log of 2 y prime is equal to 2x, which I think is the same thing I have here. Sure looks like it. So finish it this way. But then you're not done, because really it's asking for the slope of the tangent line at the point 1, 2. So you take this thing, and you change all the x's into 1s. So you get 2 over, and you change all the y's into 2s. I think I copied those all right. 2 times 1 divided by 2 times 2 plus 1/2 minus 2 squared natural log of 2. So you get 2 over 4.5 minus 4 natural log of 2. And let's go ahead and call that good enough. If you felt like simplifying that, you could. Or 4 over 9 minus 4 natural log of 2. Or however else you want to write this thing. Lots of different ways you could write it. I'd leave my answer just like this, or really this is fine too. My purpose in doing that is I thought that I would make your life easier. I'm not sure that I did, but whatever. I'm going to call that good. This video is getting long.